Using these properties then, in example 1 and example 2, where the coefficients are all proportional as well as the constant. In example 2, the coefficients are proportional but not the constant. So the first one is infinite solutions, the second is no solution. So we're going to determine whether we have 0, 1, or infinite solutions. So looking at A, equation 1 is 2x minus 7y equals 10. We have 4x minus 14y plus 9 equals 0. Looking at the coefficients, they are in a 2 to 7 ratio, 2 to negative 7 ratio, 2 to negative 7 ratio. So they are parallel. The constant term is not in the same proportion. Okay, this is not a times 2 from here to here, so we know that this is parallel, but not the same. Therefore, 0 solutions. Okay, so they're parallel lines that don't touch. And it is inconsistent. So if we solve this, we'll get something like, in this case, we'll probably end up with 0 equals negative 29 or something like that. So the B, we have, if we look at the ratio of the coefficients, 3 to negative 2, 3 to 22. If we move that y to the other side, so 33x minus 22y minus 99 equals 0. Okay, we can see that the 3 to 2 ratio, negative 2 ratio exists in both equations. They are parallel. The proportion in the sign is the same, so this ends up, I should maybe move this over, a little bit easier to see. So we end up equal to 99. This is a times 11 factor. The constant has a times 11 factor. So these are not only parallel, but the same. Okay, therefore, we have infinite solutions. And this would be a consistent system. If we tried solving this, we get 0 equals 0. For C, looking at the coefficients, again, I'm going to maybe move this over. So I get 10y plus 6x plus 8 equals 0. We can see that the ratio of the coefficients, 5 to negative 3, 10 to 6. Well, the ratio is the same, but the signs are not correct. So these are not the same slope. So these are not parallel, which means then that they must meet. Therefore, one solution. Okay, so this system has one solution.